Welcome to RUWEL International, one of Europe's leading PCB manufacturers. Let us start our factory tour in our fully automated base material storage. All base material handling takes place without any manual involvement and is fully controlled and monitored by barcode. Coming out of the storage, the inner layer job is placed on one of our automated pre-clean lines, still without any touching by the operator. After this chemical cleaning process, the boards will enter our state-of-the-art Class 10,000 clean room. Next step in the production process is to apply a UV photosensitive film on the inner layers. The inner layers, laminated with this UV-sensitive film, will be placed on our newest direct imaging system for exposing the inner layer pattern. Also, this DI exposing system is fully automated, and with its Blu-ray diode exposing technology, it combines very high production throughput with excellent quality and a layer-to-layer accuracy of up to 5 microns, which is still very unique in present inner layer exposing technology. After exposing, the inner layers move into our develop, strip, etch line. In this process, all non-exposed areas will be washed away during developing. The exposed copper beneath it will be etched, and finally, the dry film will be stripped off. After the structuring of the inner layer pattern, the inner layers continue their process into our AOI department. During AOI, all inner layers will be inspected 100% on our AOI machines by comparing customer CAM data with present status of the inner layer. Before entering the final multi-layer pressing process, all inner layers will be treated in our multi-bond process. This process will provide a perfect topography of the copper surface to ensure a very strong and reliable bonding with the resin during the following multi-layer pressing process. In our multi-layer assembly area, the inner layers are fitted together with the pre-pegs and copper foil. This assembly of the multi-layer package is done by riveting for standard multi-layer constructions and by weld bonding for more complex high layer count multi-layers. In the following production step, these multi-layer packages are pressed together under controlled pressure and temperature to a final multi-layer. RUWEL has a fully automated multi-layer pressing center, which includes 5 hydraulic vacuum-supported heating presses and 3 cooling presses with automatic separator plate cleaning and automatic return of the press tools to the layup area. Now, in the next step, the positioning of the inner layers is checked by X-ray and on the same equipment. Also, the pinning holes for the upcoming drill stack will be drilled. Equipped with the latest technology in X-ray optics, our equipment is able to check even multi-layers with a very high layer count. After edge beveling, rounding of the corners, and multi-layer thickness control, the multi-layers are now ready for entering the outer layer production. Before the drilling of the multi-layer takes place, the outer layer production process starts with the assembly of the drill package. Now, the boards are ready for entering the drilling department. With more than 120 high-tech drilling spindles available, RUWEL has one of Europe's most advanced drilling departments with a very high capacity. RUWEL's drilling department is equipped with machines for mass production as well as machines for QTA and small lot production. Next to our well-equipped mechanical drilling department, RUWEL recently also invested in state-of-the-art laser drilling equipment with automatic loading and unloading systems. These hybrid CO2 UV laser drilling machines provide excellent quality of microvia holes in combination with high production throughput. Also, all our latest investment in drilling machines are equipped with linear axis technology, and also more than 95% of our drilling machines are equipped with automatic loading systems to eliminate operator handling and reduce machine downtime. All the drilling equipment is also monitored by uptime control software to eliminate machine downtimes to the absolute minimum. In the next process step, the boards are entering the PTH department. During this chemical process, a conductive layer is applied to PCB, resulting in a perfect through-hole connection from top to bottom and all inner layers connected to holes. With its 3 production lines, depending on customers' demand, RUWEL can provide traditional D-smear, PTH and flash plating, as well as direct metallization for HDI boards and high-frequency radar board production. In the following outer layer exposing process, again, the PCB exposing step is completely digital. Also here, the exposing is performed with a fully automated DI machine, also based on modern Blu-ray diode technology, resulting in excellent quality, high throughput, and no manual handling. For electrolytical copper and tin plating, RUWEL has production possibility on 2 different plating lines. All copper plating is based on pulse plating technology. Also, at our plating department, we focused on a high level of automation to reduce operator handling to a minimum. Due to some unique plating technologies, RUWEL is able to produce PCBs with very high requirement to surface copper distribution in combination with perfectly plated micro-vias. For this reason, recently, RUWEL invested in a new plating line with optimized plating window control to achieve even better copper distribution needed for high-frequency radar board production. Before entering the AOI outer layer department, the panels go into our strip, etch, strip line. In this line, subsequently, the dry film will be stripped off, the exposed copper will be etched, and finally, the tin that was used as etch resist will be stripped off. In the AOI outer layer department, all boards will be checked again 100% against customer data. The boards are inspected on one of Europe's few fully automated AOI inspection lines. After the inspection, the boards will be checked on the offline verification stations to secure optimum line uptime. In our physical laboratory, we perform microsections of every production lot in different production stages to ensure highest quality to our customers. Next to the microsection inspection, RUWEL has all the needed equipment in-house to check the long-term reliability of the PCBs produced. This includes soldering testing, thermal cycling testing, humidity storage, CAF testing, and SEM microscopy. In the next step, the solder mask is applied to the boards. Next to our existing high-volume curtain coat line, recently, RUWEL invested also in a high-volume spray coating line. With this additional spray coating line, RUWEL is now able to switch very fast to different colors of solder mask without facing big production stops. Next to our present automated UV exposing system, RUWEL also invested in a fully automated LED DMD-based direct imaging system for solder mask. By doing this, RUWEL is now completely digital regarding imaging processes for QTA, small and medium volumes. From interlayer process to outer layer production, now up to solder mask, RUWEL is now ready for entering the digital age. RUWEL is able to offer all possible surface finishings to the customer. Next to immersion tin, hot air solder leveling, electroless nickel gold, we can also offer all possible surface finishing available in today's market. Almost reaching the final production stage, the working panels are now routed to final customer dimensions. After cleaning the boards, they move into our electrical testing department. Next to our grid adapter testing equipment, we also invested in fully automated flying probe testing equipment to save adapter cost for the customer and to speed up production time for QTA and small volume orders. The PCBs now finally arrive at our final inspection department. Before packing the PCBs and sending them to the customer, all PCBs will be fully inspected according to customer requirements. Due to the fact that PCB layout density is increasing year after year, RUWEL invested also in a fully automated AFVI inspection machine. RUWEL International, ready to face the future challenges in European PCB manufacturing.